Now in this question we're asked to integrate 1 over 4 plus the root of x minus 1 with respect to x, with x going between 2 and 5, using this substitution, x equals u minus 4 all squared plus 1. So how do we do integration by substitution? Well, if you're unsure of this, you can always look on my website for tutorials on integration by substitution. But as a brief reminder, we use this formula here. The integral of any function of x with respect to x is equal to that integral of f of x multiplied by dx du integrated with respect to u. It's as if these two du's cancel out, leaving us with f of x dx. So in order to do this integral then, I've got to prepare the way. I've got to find out what dx du is, say. So knowing that x equals all of u minus 4 squared plus 1, I can therefore differentiate this with respect to u and get dx by du. And we're going to need to use the chain rule here. So we're going to have 2 times u minus 4 to the power 1, or just simply 2 times u minus 4, and then we multiply it by the differential of what you see inside the bracket. So differential of u is just going to be the 1. And then differentiating the plus 1, well, that goes to 0. And we can tidy this up. We then end up with 2 lots of u minus 4. So that's dx du taken care of. Now for f of x, we've got to change it into u. And I can kind of get a sense that if we rearrange this for u, I've got a feeling we're going to get this denominator here. But let's just do it. Let's take 1 from both sides, and let's just put also as well. If we take 1 from both sides, we're going to have u minus 4 all squared is going to equal x minus 1. Square root now both sides, and you've got u minus 4 equals the root of x minus 1. And then if we add 4 to both sides, we get that u equals 4 plus the square root then of x minus 1. So indeed that denominator works out really nicely as just simply u. So what we've got here then is 1 over u. So we'll just put that in as 1 over u. And it's multiplied by dx by du, which we've got up here as 2 lots of u minus 4. So we can put that in as 2 times u minus 4. And that's integrated now with respect to u. So I put du there. What we need to do now though is change our limits, because we're integrating with respect to u, not with respect to x. So for those limits, what we can do now is say, well, when x is 2, work out what u is, and we can go from this formula here. So if we just put when x equals the lower limit 2, we find that u equals 4 plus the square root of 2 minus 1. Well, 2 minus 1 is 1, the root of 1 is 1, so 4 and 1 is 5, so u equals 5. So put that limit there as 5. And for the upper limit, when x is 5, let's just say when x is 5 here, what do we have for u this time? Well, 5 take away 1 is 4, the root of 4 is 2, so 4 and 2 is 6, so u equals 6, that upper limit there. Okay, so we've got that. Now we've got a nice integral here. We can pull out the 2 in front of the integral, and then we've got 1 over u multiplied by u minus 4 integrated with respect to u. And to do something like this, I forgot my limits there, didn't I? So we got 5 there and 6 there. But to do something like this, I'd now want to expand the bracket. So we've got 2 times the integral from 5 to 6, and 1 over u times u is just going to be 1, and then we've got 1 over u times minus 4 is minus 4 over u, and we're integrating that all with respect to u. So the integral of 1, well, that's easy. With respect to u, that's going to be u, and the integral of 4 over u is going to be the natural log of u. So we've got this minus here, so it's minus 4 times the natural log of u. We should really put that in a mod sign, and we're going between 5 and 6. Substitute our values in now, and we have got 6 first of all, so it's going to be 6 minus 4 times the natural log of 6, 6 being a positive value, so I don't need the mod there. And then put the 5 through, and we've got 5 minus 4 times the natural log of 5. So put that in there. Okay. Now let's tidy this up. We've got the 2 there, and we've got 6. Take away that 5, so that's 1. And then we've got, what do we got? Oh, we've got plus 4 natural log of 5. So I can see that we've got 4 natural log of 5. And we've got minus 4 times the natural log of 6. So I could actually factorize this, pull out a 4. So we've got natural log of 6 in there. And when you're subtracting logs, this will be the same as the natural log of 5 over 6. So we can finish then with the exact value as 2 multiplied by 1 plus 4 times the natural log of 5/6. And there's your exact value. Alright.